Okay, good morning, students. Today we will discuss some of the left out topics. Today we'll look at iter tools, func tools, and voice module. So, to start with the iter tools, so iter tools, as the name suggests, they stand for iteration tools. And let's see how many iteration tools are available for us. So, if I import iter tools, do a directory of iter tools, okay, and you have so many. So starting from accumulate up until zip longest, you have a lot of iter tools. We will see each and every one of them so that are available for us. To start with, we will look at combinations, okay, and then we will see permutations, and then we will see combinations with replacement, okay. So So permutations we already know. Let's just say there are five students: 1, comma 2, comma 3, comma 4, comma 5, comma 6. There are six students, and there are only four chairs: chair 1, chair 2, chair 3, chair 4. Okay, these are 1, 2, 3, 4, four chairs. Now, what permutation says is how many different ways can you take four students, any four students out of these six, and make them seated. Okay, that is what permutation is about. Permutation is how many different ways you can take students and make them sit in the respective positions. So, formula is given by NPR equals to n factorial divided by n minus r factorial. Let's just say I have a list of 1, 2, 3, 4, 5, 6, and then I want to do permutations. Okay, first I'll have to also import. I've imported iter tools, so I will say iter tools dot permutations. Okay, permutations of a comma first a comma 2. First I will check if I can seat them in two chairs, and how many. If yes, then how many ways can I do that. So if you notice, these are the so many ways you can make two students out of six students sit on two chairs. So 1, 2, if you notice something, 1, 2, and 2, 1. So basically you are taking two students, they are swapping the places and they are able to sit. Likewise 1, 3, 3, 1, 1, 4, 4, 1, that way. So repetitions are possible, it's just that the arrangement changes, okay, in permutations. Now let's look at combinations. Now combinations are very similar to permutations. The only change is uniqueness. How many unique ways can you. Okay, even before combinations, we can look at how many different ways you can make four students sit. Okay, out of six. That is equal to, okay, there are so many. 360 different ways you can make four students sit in six chairs. Okay. Um, and now let's look at combinations. In combinations, the difference is uniqueness. How many unique ways can you make four students sit in four chairs out of six such that there are no repetitions? Okay. So, and this is given by r factorial into n minus r factorial. The formula is given by n factorial divided by r into n minus r factorial. So if I do the same thing, but instead of that I'm gonna do a combinations, okay, and I will take the same thing. Notice something, there is no, if there is 1, 2, there is no 2, 1, because same students are sitting, right? Unique different students should sit. So that's why the combinations are 15 here. And if you take four chairs instead of two, then the number increases. But instead of 360, you only have 15 unique ways in which you can make the student sit. There is not a single repetition wherein which same students are sitting. That is the difference. Now combinations with replacement, what we are saying is, okay, we are gonna make the same students, sorry, unique students set, but with an exception that in two different positions you can make repeated students set. For example, 1 and 1. This is first position, this is second position. Two different position you are making the repeated students set. See this? Okay. Maybe you'll better understand this where if I take increased value. Okay. Here let me show you. 4 and 4. If you notice, what we are saying is, okay, generate the combinations for 4 chairs out of 6 students, but allow 4 different positional exceptions. Hence, this entire 4 digits are repeated. Likewise, because 4 is repeated, 2 is also repeated here. Okay, anyway, so here again 2 2 2 2 will be allowed combination. Likewise 3 3 3 3 will be allowed combination. Okay, so this way repeated ways are there. So totally 126 different ways you can make 4 students sit out of 6. Okay, this is about combinations with replacements and permutations. Easy, right? Very straightforward. Now our next topic is, we will talk about drop while and um, take while. Now drop while and take while, so let's just say there is a function is underscore even. Okay, here we are just trying to calculate, we are trying to check if the number is divisible by 2 divisible by 2 and the end result is 0. Okay, and we have a list 2 comma 4 comma, okay, 18, let's just say 14 comma 18 comma 13 comma 22 comma 23 comma 24. This is my list. Now what I'm trying to do is, I'm collecting the result in list, and I'm applying itertools dot drop while. Drop while will take the function, okay, is even function, and apply it on that list that has been created, and I'll be able to get the result. Basically, let me type this for take while also, the simultaneously I'll explain. So if you notice something from this list, complete list, drop while will keep on dropping the values, deleting the values wherever this condition is met. Okay, so drop while drops the values where the condition is met or true. Okay, here it is dropping, here it is taking those values, takes the values, accepts the values. Okay, accepts the values where the condition is met. Condition was to check if a number is divisible by 2 and the remainder was 0, and we kept on dividing. 0 divided by 2 is 0, the condition is met. Okay, hence the 0 is taken. Likewise 2 is taken, 4 14 18, all even numbers are sorted out using take while, applying this function. Okay, I hope this is clear. Drop while is dropping the values based on condition. Take while is taking the values based on condition. Okay. And the next thing is accumulate. Okay. Accumulate. Let's just say I have that list. Same list only I'm gonna use. LST. Okay. Here I'm saying you collect the values in accumulate. itertools dot accumulate of, let's just say, list. If I provide only the accumulate part, okay, notice what happened. Accumulate is basically generating the cumulative sum. The elements were 0. First I will write down the elements, okay, then 14, then 18, then 13, then 22, then 23, then 24. So these were my elements. Now what accumulate is doing is, first it will be 0 only, then 0 plus 2 is 2, 2 plus 4 is 6, 6 plus 14 is 20, okay, 20 plus 18 is 38, again 38 plus 13 is 8 3 51, right? So 41, what is that? So 51, okay, so 38 plus 15 is, sorry, 38 plus 13 is 51, and then to that you add 22 is 73, correct, and to that 73 you add 23 is 96, okay, and to that 96 you add another 24, you get 120. So basically it is trying to generate the cumulative sum. It is adding 0 plus 0, here it is 0 plus 2, 0 plus 2 equals to 2, here 2 plus 4 equals to 6, here again 6 plus 14 equals to 20. That way the total sum follows. So last two numbers it is adding, cumulative sum it is adding, and it is giving. But you can do one more thing with accumulate. If you import operator, and operator itself offers a lot of things, okay, like addition, subtraction, etc. You can apply that cumulative sum, cumulative uh, operation, okay, over a. So this is, I'm saying operator dot multiplication. Now I don't want addition, instead I want to get the cumulative multiplication, cumulative product at the end. Okay, a is not defined, so it has to be our lst. Accumulate is not defined, okay. So itertools, why is it 0? Because there is 0. If I remove this 0 from the list, let me provide a custom list, okay, different list, 1 2 3 4 5. Now see, so basically what is happening here is, it is in the first step it has only 1, second step it has 1 into 2, third step it has 1 into 2 into 1 into 2 into 3, fourth step it has 1 into 2 into 3 into 4. Likewise in the fifth step you have all these numbers multiplied by 5. So that's how you are able to get 120. So all these values, okay. Likewise you can also apply list of accumulate of um, your list, okay. I will use the same original list comma operator dot sub, okay. So you'll get the subtraction, difference between elements. That is about accumulate. The next one is cycle. Now cycle can be compared to your, literally the cycle pedal. It goes up and then down, goes up down, right? So in a circle fashion, right? So that is what is happening here. So from, I will say from itertools import star, I'm importing everything, b is equal to itertools, okay. I will directly say cycle of, let's just say morning 1 2 3 4 5, okay. And if I type b again, you'll get the iter tool object, okay, or function object. But to get the next element, you can just say list of okay, list of b. If I do, it will go in infinite loop. For cycle, you have to specify how many times do you want to cycle. See, cycle, if you keep rotating, it will keep on rotating in a loop, right? But you'll have to specify how many times you'll have to cycle that. So that's why list of b don't apply. I will delete this part, very dangerous, because it will go in next loop. Instead, I will say next of b for I in range of 0 comma 30. 30 times I want the repetition. If I do that, okay, b is not defined. If I do that, you will see morning it started 1 2 3 4 5, again morning 1 2 3 4 5, morning 1 2 3 5. That way it will go 30 times. Okay, so that's all about cycle. The next thing is product. Product is little interesting. So if you, let's just say you want to generate for I in range of 5 or 0 comma 5, either way is fine. For j in range of I, print j comma I. If you notice, you will not be able to get something like 0 0 0 0 0. For each 0 there is 1 2 3 4 5. Again for each 0 there is 1 2 3 4 5. That way you can't get using for loop. For that we have to use product. Okay, for x comma y in product of range, two ranges you have to provide. Okay, for each range it will iterate the other one. So print x comma y. See, for each 0 there is 0 to 4. Again for each 1 there is 0 to 4. Each 2 there is 0 to 4. That way it goes on. Okay, this you can do for abcd also. If you type a comma b is equal to 1 comma 2 comma 3 comma 4, and then you also have alphabets like a comma b comma c comma d. So if you have these, okay, you can say for I in product of a comma b, I wanna print I. See, for each one there is abcd, each two there is abcd, that way. Okay, next one is itertools count. Now this count is different from the other count. Other count, if you had a list equals to or we already have lst, right? No, it's not there. If you had lst like this, a list like this, what you would do is list dot count of let's just say 3. You would get this list method. This was previously, this is how it used to be, but itertool count is different. Okay, itertool count is, let me show you. If I type for num in itertools dot count of, you have to specify the start value where you want to start the count, and where do you, how many steps do you want to take during that count. And if you type a print a number or print num, that's what we passed, right? And you have to add a condition also. Okay, if you don't add a condition, what will happen? It will go on infinitely. So basically count is you're providing a starting value along with a step size, and along with a step size you will get so many count values. Here the count is counting only one element. Here it will count from starting to end, how many values are there, it will print. Okay, that is the difference. So next one is chain. Now chain is mainly used for generator objects. Okay, here let me return generators objects here. Okay, 1 comma 2 comma 3 comma 4. This is called as generator comprehension. So we already saw this in while studying the comprehensions, right? So b is equal to x for x in, let's just say 7 comma 8 comma 9. Now all I'm saying is, okay, I can't apply join operation to something that are not strings. So remember this point. Join method can only be applied for okay. Now if I applying a join with a space, I'm applying chain of a comma b. I'm asking it to chain it together. Now if you notice 1 2 3 4 7 8 9. This you could have also done by providing a list. Okay, if you do the join on a list element wherein which you have a comma b. Okay, okay, here a and b are generators, so you have to provide direct list. If you do provide a direct list here and do provide a direct list for a b value as well, you can do the same thing. Okay, okay, not join plus, sorry. Okay, now you see you are able to get the same thing, same result, but the difference is this is applying to a generator, this is applying to a proper list. That is the difference. Is this clear? Okay, if there is no answer, then I would understand that it is clear, so I'll move on. The next thing is zip and zip longest. Okay, zip comma zip longest. Now for zip and zip longest, you have to understand how zip works, and then I'll talk about the zip longest. So let's just say I want to have a iterator here in a list comprehension in such a way that I want to have two different, one is a list comprehension, another one is a list normal list, such that I want to get, and at the end I'll get list only. Okay, if I run this, if you see a comma b, if I type a comma b, you see a and b are lists only. So but for these two lists I want to zip them. You know how a zip works? Zip on a back, it takes one from left side, another left string on the right side, and then it combines, right? That is what zip in real world works. Zip on your bag, if you zip, it is taking two different things and joining them. So exactly the same thing is being done here, but in programmatically. So if you take zip of, if you apply zip of a comma b and then print the final result as x comma y, see what is happening. One element from one list, another element from another list, they are being taken, they are being joined together. So for there is space. And if you take notice, zip is only able to take whichever has the least number of elements, only those many elements will be taken. This is where the difference is. Zip longest on the other hand will try to combine, okay, all the elements. See, none, so none are added for rest of the elements. Okay, hope this is clear. Now likewise we also have is slice. Now someone in your class, maybe your class or the other afternoon batch class, so they asked me a question: if we are doing a generator, fine, we are iterating from starting to beginning, but how would we access elements of a generator from the middle? Okay, so that is made possible with islice. Okay, islice will allow us to access elements um, from the middle. So I'm just creating a simple generator functions. See, if I add yield keyword, then it becomes a generator function. If I add return, it becomes a normal function. That is the difference, you remember. And now what I'm doing is I'm trying to access islice of gen function comma 13. Okay, if I do this and then I do a print part, see what is happening. This is my generator function, but the generator function ends at 50. Okay, but I want to access only first 13 elements, so I'm accessing here. Likewise you can access another way also. If you want to define where you want to starting value, okay, ending value, and then increments also you can define in what increments you want to access. See, from it is generating 13 because you are adding n plus or equal to 1, right? Whatever the n value you pass, you for that you are adding 1, but otherwise it is ending before 30 and in increments of 2. Okay, that is the use of islice. The next is star map. Okay, so star map is quite interesting. So let's just say you have list. Okay, in list you have nested elements 2 comma 5. Okay, or let's just say you have 3 comma 2, or let's just say you have 4 comma 3. So this is my list. The difference between map and star map, I will okay, let's add map also, map and star map. Okay, the difference is here li is taking, let li be my list wherein I have nested elements. Okay, and this is my li, and what is my list? List is not defined. What about lst? Okay, lst is defined as 1 2 3 4 5. Okay, these are two of my different lists. Now if I apply map, list of map of certain function like lambda x, wherein which I want to multiply each element to of the values with values of a list with 2, I will return this. Okay, if I return this, notice what is happening. I had 1 2 3 4 5 to that 2 4 6 8 10. So it became 2 4 6 8 10. That is what my map does. It takes a normal list. Now this is where the difference is. While a map takes a normal list, star map takes a nested list. And in a way it takes is, because you have two elements, you have to pass y also here, and because you have y you're passing, you'll also be calling y value. See, what this is doing is, here I have asked it to multiply x into y, so it's multiplying. 5 into 2 is 10, 3 into 2 is 6, 4 into 3 is 12. Okay, if I add another star there, so it will calculate the power. So you have 32, 9, 64. 2 to the power of 5 is 32, 3 to the power of 2 is 9, again 4 to the power of 3 is 64. 16 4s are 64. Basically 4 4s are 16, 16 4s are 64. This is what star map does for us. Okay, that is the difference between map and star map. Okay, the next one is very interesting as well as little confusing, but pay attention please. So T, okay, T is, it will take a list and convert it into a generator. Okay, this I can demonstrate using a example. Um, let's just say I have okay, let me define a iterator first. T of good morning. Okay, good morning comma 1 I will pass, one take one element at a time, so that way. So if I print it1, it gives me a generator object, and to this generator object if I go on to pass gen of range of, no, not this, let's just say I want to access the first element, I can apply it1 is equal to t of good morning comma 1. Okay, it's a generator object for sure. Okay, what if I delete this? Okay, from iter objects, let me see if I made any mistake, because ideally it is supposed to iterate in a way that it generates a iterator. Okay, let me not even assign this. It's a iterator object, but it's generating it as okay. Let me type it as for I in t n is equal to 2. Okay, n is equal to 2. Print I. Okay, it's just generating a generator object. Okay, don't worry about this t, I will come back to it. Okay, for now just ignore it, I will explain you again. Ideally it is supposed to generate a generator object, but anyway. So next, moving on, we have filter false. Now filter and filter for, anyway we will talk about filter in the other section of func tools, but here also let me show you the difference. Let's just say I have a function called filter function, wherein which I am passing a value as y, and I want to return all the values that are less than 5. Okay, um, and if I have my list object, wherein which I have starting from 11 comma 10 comma 2 3 4 5 6, okay, and then 7 8 9 10, okay, sum of something like this. And if I want to apply, let me define this first. Here I will add a topic as filter and filter false. This is my list, and to this list I want to apply filter. Okay, how do I apply? First I'll have to collect all the elements into a list, because filter is only going to generate a function object. So apply a filter, and filter applies to a function, so that's why I'm passing a function and passing a list. See what happened? Filter filtered this list based on the condition, wherever y was less than 5, filter collected those elements, or I will say less than or equal to 5. Now if I execute, I got 5 also, 5 is equal to 5, right? So that's why. But if I apply a filter false, it does the opposite of it. Okay, it collects all those elements that do not meet that criteria, that condition. Okay, is this clear? I hope this is clear, because they are very straightforward. Filter, while filters a list based on a condition and collects the elements where the condition is met. That is important. Where the condition is met, those elements are collected. Collects where condition is met. Now filter false collects where condition is not met. condition is not met. Okay, so that is the difference, filter and filter false. Next thing is compress. This is another iter tool, and this compress is not the same as your OS compress or file compression that you do using WinZip or WinRAR. This is different. So here the way how compress works is, let's just say I want to collect the elements of compress, and I'm gonna apply the compress in such a way that I have A B C D E, and to this I want to provide values as true comma false comma true comma false comma true. So if I apply these values, okay, and wherever I see true, I will get those end result. Okay, so for true A is accepted, false B is rejected. For C is printed because it is true. Again D is ignored. E is printed. You see A B C is the end result. Okay, and as we already discussed in while discussing logical operators, every value that every number that is other than 0, okay, other values than 0 comma empty string comma empty bracket comma empty square bracket comma none, so these are all classified as false values. So if I replace this false value with a 0, or if I replace this value with an empty string, you should get the same result because these are treated as false values. Okay, so pretty much that's it about compress. The next one is repeat. Now repeat, as you know, the name itself suggests, okay, it repeats whatever you provide. For example, whatever the value you wanna repeat it with. For example, you already have a list, right? If you want to repeat it certain number of times and collect it in a list, then you say list repeat whatever the list name was and how many ever times you want to repeat it. You see, list is created as a nested list so many times. Okay. Okay, the last one is partial. Sorry, pairwise. My bad. Pairwise is if you wanna collect the elements of pairwise in such a way that, let's just say you have a list, nested list basically. You have a nested list and you want to pair the elements, even not even nested list. If you have 1 comma 2 comma 3 comma 4 comma 5, if you generate the input, you see how it is pairing. First and second element are paired, second and third element are paired, third and fourth are paired, and fourth and fifth are paired. Or if you had another example where in which you had a nested list of these two, and again these two, and again this, and or maybe this single as a single element. You see the way how it is paired is, this is taken as one element, this is taken as another element. So it's pairing, this has paired with this one, and again second element this has paired with this one. Understood? Hopefully this is understood. um, we have covered almost everything. Don't worry about t. T is used for generator, converting a list into a generator object. But if you have followed all these things, then well and good. I will share the notes and files in the drive, and we will see in the next class, we will see func tools. Thank you very much.